One of the best ways to become a better Python developer is to get your reps in. Every time you solve a problem in a new way, you're improving your skill as a developer. That said, if you're not developing reusable functions that will work across multiple projects, you're probably wasting time solving the same problem over and over again. Developing your own library of universal utility functions is one of the best ways to level up as a Python dev. And in this video, I'm going to walk you through 6 of my most used utility functions to give you some inspiration. Hey friends, welcome back to the channel. If you're new here, I've spent years teaching scientists, engineers, and developers how to write clean, scalable Python code, and my goal here is to help you spend less time debugging and more time designing. Whenever you're ready, grab your cup of tea, and let's dive straight into these 6 utility functions you need to be using in your Python projects. I use this function in just about every project I work on. Whether you need to write a log file to disk, create a directory for temporary intermediate files, or are exporting results from a batch process, you've probably been hit with this error at least a couple of times. File not found, the folder you're trying to write to does not exist. You could manually create a folder in your target destination using the File Explorer. It's much more convenient to instead use a utility function to check if the target folder exists, and if it doesn't, create it automatically. This function will do nothing if the path it's passed already exists, and is designed with a try and accept block to fail gracefully if you accidentally pass it an invalid path. While exception handling is generally not the best practice for control flow in your programs, in this case I find it the most effective and readable way to deal with this potential situation. Using return values and additional dialog statements is optional. In this case, I'm returning a boolean, whether a new folder was created or not, and have set most of the dialog to the debug logging level, so you won't see it unless you set your logger to print debug messages. Print statements are fine, but log statements are better. Not only do they look a lot cleaner and more professional, but logging allows you to set the priority level of each message. When everything in your program is running perfectly, you can keep your console clean and easy to read. If you need more detail about your program, you can flick on Detailed Debugging Messages by changing a single argument. If you're not already using logging in your projects because setting up a logging manager is a tedious process that often feels overkill for your tiny program, then using a general logging configurer will make it infinitely easier to drop logging into any script or program so you can finally say goodbye to print. I really like this variation of a logging configuration function because it features an explicit argument to enable or disable saving a log file to disk. Most of the time I don't need 100 log files spawning from each iteration of a testing pipeline, so I typically have this flag set to false. Once ready to use the module in production, I just need to change the flag and logs will start saving, immensely helpful for evaluating usage patterns or catching edge case errors. Suppose we have a process that searches through nested directories to pull out folder names which correspond to labels describing the data contained in each folder. We don't know ahead of time how many items will return, if any, from each directory path, so the most flexible way to collect these labels is to create nested lists where we append each label we find. What was a convenient and elegant solution to one problem is now the cause of another. Nested lists of uneven sizes are not at all convenient to work with. To homogenize our data, we can flatten all of the sublists into just one list. With our lists collapsed into a single iterable, we can move forward with our program and use this for something like a process queue or labels for our data. Here's another short one, but its simplicity makes it useful in a wide variety of situations. Say we're running a multi-threaded process and want to aggregate and validate the return values to keep track of which processes completed successfully and which ones failed. If our method is set up to reduce the process ID on success and none if it does not complete successfully, we can quickly filter the return list to drop all of the none elements and only keep the valid IDs. With this record of successful processes, we can, for example, track down which ones failed and investigate why. If you can think of another situation where you would use this none purging method, drop your idea down in the comments. If you're like me, pandas is your go-to library to structure any data that you're preparing to plot in a visualization. One of the easiest ways you can make your figures look significantly more professional and readable is to use data labels in your figure legends that are formatted for reading, not the internal mess of abbreviations and underscores that make perfect sense to you and only you. This function is a quick and efficient way to rewrite your data labels from whichever internal naming system you're using to something that anyone viewing your figure can understand. In this approach, we're using the DataFrame's built-in replace method. We're simply passing in a pair of strings to specify the string already in the table and the more readable one we want to replace it with. Because the replace method takes these as positional arguments, I find that unpacking a tuple of the before and after spellings to be a dead simple technique that is both easy to set up and easy to read. As an added bonus, the replace method will only work on matches and it won't fail if it doesn't find any, unlike some other solutions you may have hacked together to replace strings in your projects. So, if a label is present in one data frame and not another, you can still use the same rename map without worry that you'll get hit with a value error. This one is obviously pretty specific, but it's also so incredibly convenient when you do need to use it. Modern computing has made us largely inattentive to memory efficiency, because our hardware often has an order of magnitude more headroom than basic Python programs require. However, if your workflows have you working with large data objects and high-throughput pipelines, like image or video analysis, or if you're training computer vision models on your system, you can quickly begin to eat gigabytes of memory in a single data load operation. The sys module in the standard library has a built-in getSizeOf method to get the byte footprint of a Python object. However, on its own, it's relatively limited in terms of what it can accurately measure. In particular, it fails to correctly determine the real footprint of container objects. For example, sys.getSizeOf accurately calculates the memory size of a NumPy array representing a single 4K image. When we construct a list of 100 of these images, though, sys.getSizeOf completely fails and tells us our data structure is 0 megabytes. Using a custom getSize function, we can more reliably handle data structures of higher complexity than a single object, like a list of arrays. This function is broken into two components for readability, as the recursive inner function of the private component of the getSize function is a bit verbose in its branching logic. In this example, we'll simulate a single 4K image stored as a NumPy array, and we can see that we can correctly return its memory footprint. Logically, a single HD image should be considerably smaller. And as a sanity check, we can confirm that 4 HD frames are exactly as large as a single 4K one. This last example is closer to a real situation that you might use this in. If we're loading or processing a whole stack of images and need to keep track of the memory footprint, this method lets us see exactly how much memory is being used. These are 6 of my most frequently used utility functions. Let me know if you're already using a version of any of these functions, and which of these were new for you. If you found this video informative and are interested in learning more about saving time developing your Python projects, please let me know with a like, and maybe even consider subscribing. Peace.